All right, good morning. Welcome. Thank you, everybody who made an 8 o'clock session on a Thursday morning. That's results. Okay. So we had 60 people signed up. I thought they're never going to make it for 8 o'clock on a Thursday morning. It's like, so there may be a few people filtering in. For everybody who's playing NASA acronym on their bingo cards, today is ESCO, the ESDIS Standards Coordination Office, which is the Earth Science Data and Information Systems Standards Coordination Office. So we've got an acronym of an acronym. So that's double points on your bingo card. So what I want to do today, what I want to do is tell you a bit about ESCO, what we're doing, but really to hand this over to some of the standards, best practices that we've been looking at in the past year or so. So I'm just going to sort of say a bit about ESCO, what we do, who we are, and then we're going to have a number of presentations from some of the standards, best practices that we've been reviewing over the past year or so. And then I'd like to have a little bit of time at the end just to talk about an ongoing theme, sort of maintaining living documents. When we get sort of standards or best practices handed over to us, the team that develops them disbands, goes off and does something else, and we have a document which is great for a while, but then starts to age as things change. So this is like an ongoing problem, in lots of fields, but particularly in sort of our context, we're interested in having this discussion on what's the best way of sort of going forward with that. So yes, the truism. The nice thing about standards is that there are so many of them to choose from. I think in this community we're all agree that standards are a good thing. They aid interoperability. They help us with our best practices. But often you have multiple alternatives. So one of the things that we're trying to look at is for NASA's Earth Science Data Systems, which standards should we be using by default? So we're part of what we're trying to do is to solve this problem. So what do? We maintain a list of approved standards. You can find that on the Earth Data website. We manage the ESDIS standards process, so we have a formal process by which a standard is reviewed and formally adopted as an approved standard by ESDIS. We lead the formation of the technical working groups that review those standards and best practices. So the technical working group will be made up of subject matter experts from around the community. We organize those and bring those together as the review team. We work with ESDIS and we work with external standards organizations to monitor what's going on, look for changes that are out there that may be relevant. We used to have something called the Standards Interest Group, which has kind of faded away a little, and I'm interested in reviving that. This was a sort of our community of interest, people interested in standards. I was like, oh, that's exciting. It's important to have contact with the community, get sort of broad input to the standards process. So if you've put your name down for this session, we may be approaching you to say, are you interested in being part of the standards interest group? And then the last part, we communicate that both within NASA, within ESDIS, but also within the community that uses NASA data products. So hey, that's why we're here today. So some of our team are down on the front row here. If you'd like to wave at people, hey. Representation from ESDIS, but also from the various DACs. So lots of different subject matter expertise from different areas. Very briefly, the process. I'm going to have to send another acronym, RFC. I've got to explain this one. This is a request for comment. Our standards process is modeled after the Internet Engineering Task Force process, and they use the term RFC for change submission. So we kind of followed that. So the RFC is submitted to ESCO. The team perform an initial quality screening in terms of does it meet meet the specification for a submitted RFC, which is more about is it readable, is it intelligible, does it meet the formatting requirements for the document. So we're not trying to make a judgment on the technical content. We're just saying, does it meet the quality for a submitted document. We then establish a technical working group, TWG, another line on the bingo card. And then we'd announce the public review period. We'd circulate the document for review and comment. That period could be anything from sort of typically 2 weeks to maybe a couple of months for a long, complicated document. And then we'd have a post-review period where we'd basically disposition all of the review comments, work with the submitters on how to respond to those, and depending on the number of comments, the number of changes that were made, we may need to go back to a second round review, and eventually that document would be approved and it would be published to Earth Data. So that's really our process there. Any of us are happy to talk to you a bit more about the standards process, but what I want to do is really hand this over mainly to our presenters who've been submitting RFCs and going through the process. So the first few are RFCs that were submitted and have recently been approved. So you'll find those on on Earth Data. There are a few that are currently in the process of going through, not yet finalized, not yet approved, but getting near to that stage. And then we've got a couple that have either just been submitted or are about to be submitted. We've been notified that the authors intend to submit an RFC. So that's our plan for today. How to get involved? You can always email us, escostaff@lists.nasa.gov. We're usually hanging around at ESIP and ESDSWG meetings, Earth Science Data Systems Working Group, if you haven't got that one on your bingo card. We're very interested to hear about best practices, lessons learned regarding any of these sort of standards and specifications that are out there. If you think there should be something that there should be a standard for that we haven't got there, we'd like to know about that. That could be something we should be looking at. If you're really interested in standards and would like to participate in technical working groups, we'd love to talk to you. That would be good too. And the other thing is, just make use of the information that we've got out there. Do take a look at Earth Data, look for standards, and look at what's on the standards list. Okay, any questions on any of that? Okay, let me go back to, so we've got a number of presenters to go through. If you can all be ready and come up fairly swiftly, you're not going to get long, fancy introductions. We're going to nix one up and get you on, and then we're going to push you off. Beth here is going to do some timekeeping. We're going to, keep you to a maximum of 10 minutes. She'll start making rude faces at you and waving at you, and then Marcel will come and just yank you off if you go on for too long. All right, so Gao, we have you up first. I just got to work out how to change this.
This feels like a comprehension of all of them.
Right.
Anyway, so
Oh, right, great. Gao, do you recognize your presentation amongst these?
more than something.
Oh, no. Okay, downloads. Downloads is very hard.
So anyways, my first ESIP ever, I was sitting at
Make sure you're at the mic.
I was sitting at this standard process group meeting, which is ESCO's earlier version. And I sat there for half a day and I didn't even know which meeting I was sitting in. And thanks to Ted Haberman and Alan Doyle, after that I started making standards like ICAR standard that came out from that meeting, started from that meeting. And now I'm making more trouble, sorry. And so this is a lot done by Morgan and by many other things. And why we did this, this is what Steve asked me, why? because ASTC hosts a lot of airborne campaign data or field campaign data. Many of these campaigns have hundreds of variables. However, a large percentage, like 70% of the variables, are being repeated, measured over and over again. So when people want to look for data, like one variable or a few variables from all missions, you need a tag, because of the variable named by the PI, there's almost no rules, right? It's just like naming their own kids. So that's what started from the ICAR refreshing group, because we had some lessons learned and say, okay, we need this. And when we started this working group for the center names, their additional goals were set for this group, and because of the people in this group, modelers and also the data providers, basically said, well, first you need to cover all the measurements, which CF by far doesn't. CF only covers maybe a quarter or less for what we do. And another thing is that people, especially the modelers, say if we look at a name, it can be coded. However, we need to know all the basic information, so we don't have to email everybody all the time. And another thing is, after that, we tried. We took the approach. We had a draft. We deployed these standards to the field campaigns and got feedback. And in the end, I think we got quite a few more, probably a couple of, almost like 40% more from our origin when we first started. And now, because it's usability, I mean, the data providers like them, they're even being used right now as an ongoing NOAA field campaign called Aroma, and also being endorsed by this interagency working group, that's informal working group. So this is just showing when, for the same variable, the PI can name differently, even in the same mission or different missions. That's why we need this, part of the reason for that. So what do? We collect thoughts from the scientists, and well, in this case, not a whole lot from data scientists. That's probably is a shortcoming. And we have deployed, use these things in a number of missions. So far, nobody really hated us yet. And we did take although the IADOP approach wasn't established back then, but we did many things similar. Like as a step one, the group of people made these names, really understood what these names are, these variables are. And we did use a decomposition approach, which has some segments. Then afterwards, the reason we went through so many missions, because we have somebody like Morgan supporting it. Now we're doing a checker for good, for bad, at least they're consistent, right? So this is standard office is all about, right? And also we figured out that we can readily translate into the currently published list, the only list of actress supported by EU. This is probably the gold standard right now. This is developed from this is the student of IADOP. So this is just trying to show how these things are used. So Morgan put some blue boxes. So we use these as tag. The PIs, the data providers, still can name their own kids. However, there's tag to it. And then so this is how the DAC can use this tag to cross mission search. And also gives you the information support, not only data discovery and also data use. The little attributes are suggested by the modelers and by the data providers, trying to say these are the most commonly used information. So we did do pick and choose, not everything. Doesn't include the kitchen sink for sure. So this is one example for the trace gas. So you can the table is actually in our document, but if you look at the bottom, since gas CO2 in situ as DMF, this is just saying the mole fraction, or the proper name is a amount fraction for CO2 measured reporting in dry conditions, because CO2 is important, especially when you do the emission work. You need to report dry, otherwise the water vapor will dominate, will have a significant portion of variability. And similarly, we can have other things, right? So I'm not going to go through every one of them, but if you have questions, you can ask me later or ask Morgan, even better. So for aerosols, it's a little bit tricky. And given, well, I can talk about this later. So this is another example. When we made these names, there was a strong voice in the group saying you need to have a fixed number of attributes for each category. We did that, but now people saying you don't have to do that. But anyway, so that's just history, right? I'm taking comprehensive. I fail, so what? So this is a excuse list. And Beth, Steve, and everyone in the group gave us some real comments, and they're valid comments, right? First, atmospheric composition focus is not friendly to users at large. Okay, made by people for the people, right? So people in the group were data providers and modelers. Of course, they're going to do something they like. And this thing, it is a little bit difficult because for process variables, it's not for everybody. Because you do need some background knowledge to use this majority of the data from field campaign, because we're process oriented, right? Not the other process oriented, sorry, just chemical physical process focused. Well, governance model is a little bit tricky because let's say for fire SAQ, we added 200 variables just from this campaign alone. So if we stay like in a CF governance, will be irrelevant. People will just abandon us, right? And ad hoc variable, then yeah, we can talk about that later, and we can do better maybe. And Beth is here. So what's the next one? Yeah, the same thing I already addressed. This is why we did what we did, and like I said, this is the excuse list. It's not a people can tell me, well, you're full of it. Okay, fine. Just don't fail me. So after we did this, FAIR principle came out. Well, I do think that this has something to contribute to making data more fair. Fair is a high bar. Nobody can say the data is fair because nobody knows what fair data is at this point. I can honestly say. Yeah, we want to contribute to the UML effort because if we want to make it, because to be fair, data needs to be discoverable and usable, or I hate the word reusable. That's just one word. To make data usable, you need to really properly define the variable. Spatial temporal information is not sufficient by definition. And we need a physical chemical definition. So in one case, I say for hydrocarbon variables, you cannot just identify the compound by name just because people took organic chemistry or hated organic chemistry would know it's not unique. So in our case, our definition had a CAS number. It's a lot more unique than just by name. So in the future, we want to improve with everybody's help. Maybe the version 2 will be more user-friendly to the general users. And one thing is we can leverage the actress's definition or description because they did a careful job. They spent a lot of money, many years. We're just shoestring budget, just a few people hanging around doing the hard work at night. So anyway, and also we want to explore ways with everybody, trying to see how can we make the governance or maintenance better. And the important thing is this shouldn't be just for one DAC or for one kind of data. It should be for everybody. I'm committed to do whatever I can help, but I'm done. Oh, sorry. For the last one, just show you we're not just saying it. It does translate to actress, okay? And do I have time? No. Very quickly. Okay. Marcus Spielberg. Okay, I'm done. Now you can fail me.
All right, thank you, Gao. So Stephanie, I think you're up next. So you can start introducing yourself while I find your presentation.
Oh, okay.
Thank you, Gal. Good morning, everybody. Thank y'all for coming. Like Steve said, 8 o'clock on Thursday. I'm Stephanie Wingo. I work in the NASA Impact Group down at Marshall Space Flight Center in Alabama. We do a lot of things in my group. I lead the Airborne Data Management Group. We do more than airborne stuff, and we do more than data management. So I don't really know why we're called ADMG, but that's what they call us.
Okay.
I'll forget my water, I'm sure. Okay, so we are talking about a review that we did with ESCO on terminology and definitions that we used for developing the CASE inventory. So what's CASE mean? CASE is the Catalog of Archives Suborbital Earth Science Investigations. So field campaigns for Earth science, suborbital meaning not from a satellite in whatever form that takes. So in terms of what kinds of data exist for these suborbital efforts, there's lots of kinds and there's lots of kinds of kinds. So we've got, you know, different variables is one sort of heterogeneity that is abounds within the suborbital observations, as well as the platforms that are used, the kinds of platforms that are used, the instrumentation, the sort of science domains that are supported by these kinds of field investigations, as well as data processing, implications of that for data users, data formats. And I don't just mean digital formats. I also mean NASA's data from the 50 years of its suborbital field efforts, that not all of it is digital right now. And that's actually another part of what our group is working to improve. The point is, all of these data they're NASA data. So we have a responsibility to make them public and to have them be accessible so that they can continue to support good emerging new science that in a lot of cases, maybe we didn't have those questions around, or we didn't know we could use those kinds of observations to answer new science questions when the films were put in those cans back in time. So what's Casey doing? So we're taking all of that, all of this stuff, and trying to throw it in a box that we can, you know, deliver it to people and bring to data users to be able to actually, again, invest in new science in these observations. So, but if anyone's ever moved and you have a box full of stuff, it doesn't really help you if it's like for 5 different rooms in your house. You kind of want to have it organized in some way. So the first challenge in doing that is, what does this thing mean, right? Like, what does this mean? And we encounter, this is no surprise to, I think, anyone in this room, there's a lot of communication challenges and hurdles with that. Not that problem is not specific to suborbital data, but there are a lot of kind of intricacies within that. And, you know, I've really appreciated the interactive components of some of the sessions at this meeting. I've never been to ESIP before, so I wish I had like a Slido poll or something here to like say a word and then like get what everybody thinks the word means. There's a classic little cartoon of, you know, the kid asking his dad, so hey, what are clouds made of? You know, and I'm sure you've all seen, and the dad answers, well, it's mostly servers. And that's obviously not what the child was intending, but that's what the person hearing the question thought they meant, or how they interpreted that. And so it's kind of like, I can say blue, but well, maybe you like the big blue ocean, and so you think of that as being the sea. Or maybe you have someone in your family who's had mental health challenges, you say blue, and you think, oh, maybe that's sad, or, you know, depression, you have like a whole different thing. Or maybe you really like ELO and you think Mr. Blue Sky, and that's, you know, where you go with it. And, you know, so this is a really simple and, you know, maybe funny, but example of a really complicated problem that has a lot of challenges associated with it. So, you know, and these meanings of terms evolve over time. It can vary by discipline, varies by, you know, community that's handling it, or even data science folks, data managers and stewards, and science users and data producers. And there's all sorts of, you know, conflict that, not conflict, but friction and challenges that come in there. The relationships between those terms, how do I organize these boxes? That's really not clearly defined, and that can change too with time. So we're moving in our house. What are these sub boxes that we're trying to put our things into? How do they make a bigger box, or how do I put them in my house? And what do I put in them? How do I say what this means? So what we did for Casey. So again, we're not moving house, we're moving, suborbital observations for NASA. But one of the first things we had to do, we reached out with several of the community suborbital and airborne science communities, science domain communities, and tried to put together a data sort of model, conceptual model of how does a field campaign happen? What are the pieces that go into it? And at first we tried to think of it without labeling them. We, tried to think of it as like, go back to colors, like, okay, well, there's a purple thing, and then there's like a blue thing that's maybe part of the purple thing. And then there might be a red part in there. And then what do we call those? So then we put together kind of an early draft or early iteration of what the definitions of these various levels of information content would be. And then after we iterated on these definitions, which I'll talk more about in a moment, we put together decision trees so that our curators, who are actually really the backbone of how our Casey inventory exists, can make objective and consistent determinations when they're trying to decide what box this thing goes in, so that it's, again, less subjective. We're trying to get to the same box every time. So we did RFC process, as Steve kind of outlined. We ended up with, I think it's 16, if I counted right, various terms, which I won't read them to you, but these are the key terms that we used within the structure for the Casey data model and conceptual model. Our process timeline looked like this, to where about a year ago, a little over a year ago, we issued the first review, and that went out. We had several subject matter. We had individual science people, and then also specific data stewardship folks that participated. We had many, many comments, and we did decide that, we needed to kind of rein in some of that a bit. And so we did choose to do a second review, which we had several comments as well that we then responded to. And then I think the final version was just about between AGU and the start of this year when it was formalized and put out. And then we actually brought it to EGU this past April and had a lot of interest and positive input towards this whole idea, not just for suborbital data, but the concept of standards. And obviously everyone was happy with that. But yeah, so I have here, you can go to the site, that's the little code. And then just as in one of the terms, I just copied and put it there. One that was especially fun for me was, how many of you have ever heard of a NASA mission? And how do you define what is the NASA mission? So that was one that was particularly challenging. So we tried to keep these inclusive, but also not too restrictive, so that they can be nimble and applied to these 50 years of suborbital data. And so one thing that was very important is that for each of these terms, we have multiple examples to further clarify the intention of the use of that particular term. And that's all the slides that I have, but it's kind of an overview of what we did.
All right, thank you. I didn't pause for questions after Gao. If there's one quick question, we can.
So sorry. Thank you, Deborah.
So these are some examples of kind of local conventions. So just in sort of standards terminology. So we in ESCO I'm using two microphones here. So in ESCO terminology, we use the term standard when we try and restrict where it's a standard from an official standards body, so OGC or W3C or something. There are other things which we call conventions. So we can have local conventions within the community, whether it's just within NASA, a particular division within NASA, or whether it's maybe within ESIP, we agree a convention amongst us, but we haven't got a formal standards organization behind us. So we try to make this, that distinction between what is an official standard and then what is a convention that a community agrees to follow. So yeah, there's a couple of examples there. So next, going to invite Doug up to talk about Stack. I think you're next. I thought you were following the list for me. Sorry. Oh. Okay, so last time you got ADMG and Casey for the bingo card. We've now got Stack. Anything else coming in here?
You want me to expand the STACK acronym? That wasn't on my list of to do.
Okay.
Spatial temporal asset catalogs. As my good friend Owen would point out, STACK is much like ATM or PIN. We talk about stack catalogs, which are actually catalogs. I'm Doug. Nice to meet you. I'm going to talk about Stack. So I'm going to talk about the motivation to make this a standard. There's two main parts to Stack: the Stack catalog, as I've already talked about, which is representation of the inventory, and the API specification, which is how you search dynamic versions of that catalog, and then talk about evidence of implementation, where this thing is being used, various tools and libraries to facilitate its use, and finally, I'm going to talk about its capacity for interoperability. So, motivation. One of the key pieces of NASA moving to the cloud, as directed to us by NASA HQ, that we provide a stack catalog for our cloud inventory. So that from an EOSDIS perspective was the main motivation for this, but there are others as well. This is a quick regurgitation of the official definition of stack from stackspec.org, but the main aspects that are appealing to us are that it was tailored specifically to our domain, which is spatial and temporal. It's asset oriented. You can crawl stack catalogs so they're discoverable on the web. It's a very lean standard. The core spec is very minimal, which lends itself to interoperability. And last but not least, it's extremely popular. It's got a lot of traction and adoption in the community. So as I've already mentioned, the reason we're making it a standard, or made it a standard, is because of that wide adoption and support, and the fact that it is a key element of our cloud strategy. So the more keen observers of Stack may ask, what's this all got to do with the cloud? And that's a fair question. There's nothing in the Stack spec that says anything specifically about the cloud, but it is a very effective online catalog. And if you want to avoid our massive data lake that is Earth Data Cloud becoming a data swamp, i.e. lots of items in it that you can't find, you need an effective online catalog, and Stack is a good solution for that. So moving on to stack catalogs. Catalog is a representation of either your entire spatially temporal defined inventory or a subset of that. It's hierarchical. You have catalogs, collections within that catalog, or even catalogs within that catalog, and those collections or catalogs may constitute items, and an item is represented by a number of assets as shown in this diagram here. It's hierarchical. You can navigate through the information that's entirely inside the catalog. And as I mentioned before, it's asset oriented. It's also in JSON, which everybody loves. So a catalog contains other catalogs and collections or stack items. And in CMR, Common Metadata Repository from NASA, if any of you aren't aware of that, probably not. We modeled the concept of a catalog on our data providers. Collections are extensions of catalogs. They have additional information associated, and we might, not surprisingly, CMR models data collection on collection. And then finally, the core unit of Stack, the item, which is extension of a GeoJSON feature with an additional temporal extent. Obviously, the central tenet of stack is spatial and temporal, so we add the temporal extent to the GeoJSON feature. And that maps to CMR's concept of a data file or granule. Within those items, we have links which supply external information about that item, whether that be documentation or metadata. And then the assets themselves, science data, browse imagery. Some implementations I've seen where they reference services in the assets. And then we have the dynamic version of a catalog, which is a searchable API. Good example here is at CMR, we have stack API, cmr.data.nasa.gov/stack, queryable endpoint that will return a collection. Here's an example of us doing a search of the PODAC catalog at CMR, and we can add filters to that, like a bounding box or a temporal constraint. And then we'll get a response in the form of a collection which contains a number of features. Each one of those features describes a spatial and a temporal extent associated with that feature, and a number of links and assets attributable to that feature. Those links may be the canonical metadata, in this case, the metadata at CMR, and a reference to the parent collection. And then the assets, the data, the metadata, and as I mentioned earlier, sometimes you have services in there. And in this example from PODAC, they have a link to the OpenDAP service associated with that asset. So we have a number of catalogs and APIs software out in the wild right now. Operationally, if you look at stackindex.org, at time of writing, there were 36 static catalogs referenced there, including those which I enumerate there, and 24 dynamic catalogs or APIs, including our own CMR, Google Earth Engine, Planetary Computer, etc. In terms of software, we have things like Stack Browser, where you can point a UI at any stack compliant API and be able to browse through that in a user interface. Intake Stack, a popular package for data analysis, has a Stack extension for it. You can build your own Stack API through Stack Server, and QGIS has a number of plugins associated with browsing Stack catalog and leveraging the assets inside them. I mentioned earlier that Stack is a very lean spec to enable interoperability, and the idea that subsequent versions will maintain backward compatibility. In order to add features that we're specifically interested in, we tackle that through Stack extensions. Some of the more popular ones and more germane to our focus are listed here. That's pretty self-explanatory. Storage one is where cloud finally comes into play explicitly, where you can store in your results attributes associated with how they're stored on the cloud, like region, bucket, any credentials you need to get to that bucket, etc. And then the last two I've got here in italics are associated with extensions that are in process, which are going to help us work with interoperability for Stack. Those of you who have been to ESIP for a long time may remember the Open Search initiative for interoperability for discovery across agencies. This, I think, is a good candidate for upgrading our implementations of this federated search, moving away from OpenSearch, which didn't really gain a lot of traction in the community, to Stack. And it has all of the same criteria that made OpenSearch a very attractive candidate, and more so in other areas. I think in order to get where we are with OpenSearch, these two extensions are going to be necessary. Steve's hovering. Finally, interoperability. All of our AOSTIS data can be described in a Stack catalog, which is good news in terms of interoperability. It's a standard that's aligned with various OGC specifications, and as I mentioned earlier, it has good potential for federated dynamic catalogs across agencies. Standards are your best friend.
All right, thank you, Dave. Jeff, go for it.
Is there any effort to present the responses to the user through a code-free interface?
A code-free interface? I don't know what that is.
Like, yeah,
A what? A UI? Well, yes, Stack Browser. I'm having difficulty hearing you. Sorry, Rich.
For other data sets like model output, do you recommend people follow Planetary Computers lead? That's what I've been saying, but I don't know if you agree.
Model output is not my expertise. Anybody care to field that question? No, sorry, Rich.
All right, thanks, Doug. So our next presenter is not able to be here, Stephanie Perez. But I think Marcella is going to just briefly explain
yes.
about CNM.
And I am not the expert and I can't really answer any questions. I apologize in advance for that. But Stephanie put together some,
That's very sensitive.
it is, put together some wonderful slides about the cloud notification mechanism. Oh, arrow key better, all right. So it's a lightweight JSON-based protocol to exchange data between the provider and the archive. It's push, and there are optional response messages. Can I minimize this? Sorry, the list of people is on top of the notes for the slides. Yeah. Okay, and then there's a flow diagram. Okay. The provider stages the data in a store, in this case, AWS S3, sends the message to the DAC over a messaging service, and the message contains files for a single granule at a time. Then the DAC processes the message and optionally sends the response message back to the provider. The response contains info like the archival status, location, and the ID.
Can I use my audio
Please do.
engineer skills?
I do not have the audio engineer background. And I can't get any further from the mic without. And there are some examples which I hope you guys can read from the back of the room. But as with all our presentations, they're available in the Google Doc folder for this presentation. And I won't spend time reading. But here's the CNM, and there's also an example of the CNMR. And at the moment, SWAT, NISAR, Opera, Grace FO, and Power Tempest are using this. So, and there's also a GitHub for more information about it. And there is a page on, well, there's an upcoming page on ESCO. We're still working through the creation of that, but it's pretty imminent. We've already reviewed the document. So, thank you.
All right, so next up, Bhaskar.
Excuse me, we can no longer hear the presenters. Could you put the mic closer?
Oh, okay. Can you use that? All right, can you hear us now?
Yes.
Okay. Use the arrow keys for this? Yeah, put the arrows, go for going forwards.
All right. Good morning, folks. My name is Bhaskar Ramachandran. I'm the LADStack project scientist. And honestly, this is not my bailiwick. The gentlemen, Naveed and Kurt, are systems engineers and architect responsible for putting this together. Hang on just a second. Present.
Yeah, we just want to make sure we can see the screen share. It says we're sharing. Oh, let's share this third thing, sorry. There we go. Okay, now everyone should be able to see it.
Okay, so that's your next slide.
Okay.
Good.
Moving forward. Oh. I need to use the backward sign. Okay. Yep, I'm good. Yeah.
Okay.
So a little bit of history here. The PDR polling with what is it? Delivery protocol. It's a term we've been using for a long time. Goes back 20 years back. In an earlier incarnation, I used to be the LP DAC, and I was the receiving end. And essentially, it relied on FTP, uses username and password for authentication, and it also allowed you to use both a pull and a push. And I think around what was it, 2017-18 timeframe, there was a NASA mandate to terminate FTP. And that's when I think they switched to using secure shell with secure FTP, secure copy, etc. And then a year or so later, there was another mandate to sort of not allow or disallow SSH coming in from external sources. So about a year or two before the pandemic, I think this whole work on SDTP, the Science Data Transfer Protocol, started. Now, as far as the design goals go, they basically wanted to improve sort of security, accessibility, and provide a limited set of requirements. So it calls for both client-side and server-side certificates so that both the client and server are authenticated to each other, and the data are essentially encrypted as they are sent. Now, the protocol also calls for, read-only data, and it says, the client shouldn't have the ability to modify the state of the server. No push access, but there's a little bit of a caveat there because they do have the ability to push the acknowledgement back, and it attempts to improve accessibility, which means the number of systems across which it's applicable or it's usable. You can use it on premises, and the whole suite, cloud. I mean, the whole AWS, Google, whatever, Azure, DigitalOcean, etc. And also your, this is something which we deal with today a whole lot, the open source container systems and platform as a service systems, that sort of essentially rely on an OS level virtualization. And I know they've added something called Bare OS, which I don't know what Bare OS. I've heard of something called Bare Metal from 10 years back. Doug probably knows what Bare OS is. I didn't have time to check with these folks to find out what a Bare OS entailed. It has limited requirements. It uses Python. It requires either an Nginx or an Apache web server, and it uses Postgres. And also, I think it has a couple of modules, Python modules, Flask, Alembic, etc. Essentially, any modern Linux distribution system today can sort of handle the ability to get this framework going for you. This is my last slide. So anyone can implement this protocol based on their needs. It allows, it relies on an HTTPS-based REST protocol. The JSON payload is essentially the file list that that we use in the transfer process is defined in JSON. Allows for easy command line testing using apps like your client URL or curl, and consists of 5 basic endpoints. The get files for getting a list of files, get files for file ID to download a file, and then the delete file for basically acknowledging the receipt of files. Now, the 4th one is essentially a variant of the 3rd, in which you can define a range, start file ID to end file ID kind of a range. And I think the last one is something to do with sort of a get register for setting it up for the first time. The URL there is your link to the API documentation README file that provides all the gory details that you might want before you start implementing it. So it fully implements the above protocol with there are additional features I haven't talked about here. It does support things like checksums and tags and all that stuff. Completely open source, anyone can download and they can also contribute to it. One of our first adoptees for this is the University of Wisconsin's our ASIP Atmosphere SIPs folks, and I believe our NSIDC and LP DAC also have implementations of this, because they are the downstream DACs that receive all the data produced at MODAPs, LANSIPs, and etc. So that is sort of all I know about this. If you have any questions, etc., I'll be happy to get back to you. I kind of okay.
You can tell them if you want.
No, that's fine. That's fine. Yeah.
We now know what Barrow is.
Yeah. So, all right. That's all I have.
All right, thank
Thank
you. You have a big question there?
So it's possible I have questions for 2 people that aren't here, but it seems like this is serving the exact same purpose as the CNM, which was the previous segment. And I was wondering if there's been any effort to reconcile or deduplicate that sort of protocol of handing off from the SIPs.
Yeah, no, I had the same sort of questions when I first saw the earlier presentation. I don't know if the folks who developed this were aware of it, but definitely something I can find out and make sure they're aware of it.
All right, thank you. So we've had a couple of different things here. So what you've seen are some things which are protocols or conventions developed within NASA, but also for Stack, where we're endorsing a specification that was created by another community, and we've decided to adopt that and formalize that within NASA. So what we do as part of the our review process and the RFC process is part of it is saying what the applicability of this standard or convention is within our community. So we're saying when to use it, where it's appropriate to use this particular convention, or when it might be appropriate to use something else. So when you go to Earth Data and look at the standards, also take a look at the notes that go with those that say it's not just use Stack use Stack for everything everywhere, or it might do. But it may say, these are the instances where we think it's appropriate to use this particular standard or protocol. Rama, let me find your presentation. What are you doing, DPDG? Need to click on that to move forward. Be sensitive, you don't need to put next to it.
It's also sensitive to its center of gravity. Okay. Just a show of hands. How many people are in this room who are not affiliated with NASA? Great. I was wondering if we're going to be talking to ourselves. So, okay. I am Rama Priyan, and Peter Leonard, who is also on this presentation, is joining us remotely. Peter, are you there?
Yes, I am.
Okay, great. All right. Whatever I don't.
Rama, the bottom of the presentation is, I can't see it. Let me see. Or,
Oh, really?
okay. Maybe it was just, go ahead.
Okay. All right. So there's not a whole lot I can do about that. Okay. So there are a bunch of questions that are being answered in this presentation. So these are the topics: what, where, why, for whom, and who did it and how. And they talk about the ESCO process.
Show next slide.
Yeah,
this is the one.
I understand. I understand that. Yeah, so I already introduced myself and Peter, so I was going on to the next slide, which I have not shown. All right, let's go here. And how do I click on that? Yeah, that's where I click on. Okay. So I'm going to talk about what, where, why, for whom, and who and how, and talk a little bit about the ESCO review and publication process that we had, which is part of the how. And well, we created a version. I suppose I should go back to the previous slide and read the title a little bit. So to tell you what we're working on, it's the Data Product Development Guide for Data Producers. And so so there is a version 2 that's under development right now and under review. And I'm going to talk about that a little bit and give you a little bit of detail on the version 2. And we'll have a few comments on the future maintenance of DPDGs that I don't have on this particular piece of the presentation, but that'll be covered a little later by Peter in a later part of the agenda. Okay, moving right along. So what and where? The Data Product Development Guide for Data Producers was developed by the Data Product Development Guide Working Group, DPDG. I'm going to keep saying DPDG instead of reading the whole thing. You can add that to the bingo card as well. So it's one of NASA's ESDS-WGs. The citation for this is given there with the DOI. And there's also a quick start guide to the DPDG. And all these can be found at the link that's given at the bottom of the slide. The document itself is intended for data producers. And it is, it's got a bunch of sections. It's a fairly long document. It's, the current version the published version is of the order of 65 pages or something. And the later version is about 90 pages. But it's organized in this manner shown in this figure. We take the reader from through the process of developing the products, starting with requirements, design, implementation, testing, reviewing, and production and delivery, and so on. So this is the general flow of activities, and each of the sections, the parenthetical numbers shown there refer to the section numbers in the document. So why did we produce this? There's a large number of data products in EOSDIS. I think the CMR right now has says there are about 14,000 products in EOSDIS. These products are held at 12 DACs. Each of the DACs has its own rules and guidance for data producers. And historically, it has gone that way. And it was felt that to bring more commonality among them will promote interoperability and will be of benefit to end users. So Chris Linus, who is now retired, proposed in 2018 to develop a guide and publish it as a suggested practice following broad community review led by the ESCO. So when he proposed it in 2018, I believe it was in the ESDSWG all hands meeting in 2018. I got quite excited about it, having been involved in some of the management of the data product generating groups. So I said, okay, I'll take this on as a challenge, and decided to chair the working group, and Peter was enthusiastic about it as well. So he's co-chairing the working group. So we've been working together since then. So the intended audience is people who are involved in producing standard Earth observation data products for NASA. And this goes from science investigators and algorithm developers and DACs and data tool developers. All these folks should be interested in this document. But the primary beneficiaries of the data product, primary beneficiaries are the end users. So we make recommendations that serve end users, though they may occasionally levy extra work, but manageable effort on data producers or DACs. For example, well, we want to ask people to provide more metadata. And that'll benefit end users, but it's some extra work for the data producers and DACs. And even though it's intended for NASA's Earth observation data products, producers of other Earth observation data products outside NASA might find this to be beneficial as well. So who and how? So the DPDG working group was formed with volunteer representatives, and we had over 20 organizations, including data producers, DACs, and ESDIS Project, and others. And all these folks contributed to discussions, identification of relevant sources of information from which we should condense and write this document. And they also contributed to writing sections of the document. The document itself acknowledges all the people who contributed to the document and highlights the editors. A small number of individuals volunteered from this group of authors to form an editing team to integrate all the inputs into a readable document. So initially, when we got started, there was a lot of different styles and different levels of detail. So all that had to be condensed or integrated and made more readable. And we then submitted the document to ESCO for review and publication. And there was a process. ESCO always does a broad community review, requests the authors to indicate the useful set of authors, useful set of reviewers. And we tried to, well, we had a very broad set of stakeholder representatives that looked at the document. And the DPDG version 1 had 2 rounds of review. The first round, we got 280 comments. Second round, got 40 comments. And it's an extensive amount of, well, quite a large number of comments. A number of them were editorial comments, but there were significant number of technical comments as well. So the editing team, is a subset of authors, as I have already mentioned, disposition. Oh, am I out of time? Oh my. All right, I'll just hurry through and wrap it up. Okay. Okay, so as it's a very intensive process. You know, I don't particularly like working with JAMA, but we had to do that. And we take comments from JAMA and then because we are an editing team, we don't really want to disposition right in JAMA. We take it out into a spreadsheet and then have discussions among ourselves. And then consensus responses are included in the in JAMA. Okay, so ESCO assigned a DOI and created a landing page and made it publicly available. And you've got strengths, weaknesses, applicability, and limitations in case of all the things that come out of ESCO, which is very useful. And we created a quick start guide of the DPDG. And an update of that was produced with minor changes and was published after internal review. And now we are doing a version 2, which has undergone review. And the key change from version 1 is that airborne and field campaigns were not covered before, and they are covered now. And cloud technology was not addressed, and they're addressed now. So the status of that now is the ESCO received the document on May 6th. First round of reviews was completed June 23rd. We got over 450 comments this time. These are editorial, technical, and general. About half of them, more than half of them, are editorial. Things like a comma is missing or a comma is spurious and so on. But there were substantial technical comments as well. And we are currently reviewing and dispositioning those comments. So this shows the main big section there was section 3.3, which has got all these topics covered with paragraphs describing these. I have to acknowledge Ed Armstrong, who contributed this section to the document, as well as extensive appendices that contain attributes, metadata attributes. Other than that, I think I'm done. There's the contact information. If you have any questions, you can contact us.
All right, thank you, Rama. All right, so we'll whiz this along, but so this was an example of a different type of document. So this is, I guess, probably falls under the category of sort of best practices. It's a how-to document. So we've looked at some sort of specifications, some naming conventions, and this is a sort of a how best to do something type of document. So these are all different styles of things which may go through the ESCO process. As Rama was pointing out, the DPDG version 1 has been out for a while. That's already available on Earth Data. Version 2 is currently sort of going through the process. We're kind of dispositioning those comments. So that'll be published sometime later this year. All right, thanks, Rama. Okay, and I think our final from this category was the ESDSWG recommendations.
the IWG, I cannot share my screen when somebody else is sharing their screen. So I think it's the podium.
Yeah, I think we'll do them here. Alexander, do you want to come up and press buttons since you're a co-author on this? So we'll, Peter, we'll run the slides from here. Alexander, who's the expert on this, can.
Okay, well, Alexander just got the final presentation this morning at 4:30 a.m. So.
Okay, well,
I was awake waiting for it, so I know everything about all this.
you just do forwards and backwards and just click on there.
All right. Okay, I'm at the click button, Peter. Go ahead.
Okay, DIWG, Dataset Interoperability Working Group. Chairs are, this is an ESDSWG, myself, Alexander, and Charlie Zender. Next. Okay. It's been around for a while, and our product is recommendations, basically lessons learned, best practices. I'm going to go through this quickly. Well, there's two released documents, and we're working on the third one. Next slide. It seemed like this session was about the ESCO process, so I have these two slides about the process, but there's nothing really remarkable going on here. We get an idea for a recommendation, usually comes from within the working group. We meet every third Wednesday of the month at 2 p.m. Eastern time. And so we discuss it, and then we draft it on the Earth Data Wiki, and then we vote on it. And if 3/4 of the voters approve it, then it goes to the next level. And if not, then we try again or give up. Next slide. And once they've been approved, there is this publicly visible Earth Data Wiki page with our recommendations. But the real product is the recommendations document. And so we produce the document, submit it to ESCO, and it goes through the review process. And usually it doesn't make it through the first time. There's significant comments, and we keep fixing it up until it gets through. Okay, next slide. We got it early this year. We accepted eight more recommendations, and that's on top of the 5 we accepted so long ago in 2020. Next slide. So these are the 5 that were accepted in 2020, and I'm not going to go through them. Next slide. Except for this one. This is the smallest one that can fit on the screen. Basically, in the CF, there's this, okay, a lot of this is biased towards NetCDF and HDF5 and the CF metadata conventions, and also ACDD, which is attribute conventions for data discovery. And so CF and ACDD have this references attribute, which can be attached at file level or to a specific variable. And basically, we're recommending that they use DOIs, especially the URL form of the DOI, and have your recommendations separated by a space character. This is one of the 2020 recommendations. Next slide. Here are the six of the 8 that were accepted. And the next slide gives an example of one of them. Next slide. Okay. Avoid use of the missing value attribute. This is old and obsolete. And if you're producing a new data product, we're recommending you use the CF fill value attribute instead. And if you have your missing value as a vector, then please create a variable, a flag variable, and attach the either CF flag values or flag mask with the flag meanings attribute attached, explaining your flag values. Next slide. Okay, there's 2 that have to be reworked. They're ready to be voted upon. A lot of the stuff we're just recommending things that are well known. As I already mentioned, if you've got a UCS flag values or flag masks along with flag meanings, if you've got a flag variable, this is basic CF. Next slide. And we are also endorsing the data product development guide that Rama just described. There's a lot of overlap, so it's not as independent endorsement. Next slide. Okay, anybody who wants to participate in this working group, contact either myself or Alexander or Charlie Zender or any combination, and we will get you signed up. I think that's the final slide.
All right, thank you, Peter.
I've done my service, or I can stand here, maybe.
Oh, yeah, certainly. So DRWG is interesting. So so this is sort of third iteration of recommendations. So these have actually not yet been submitted to ESCO, but the two previous sets have and been approved. So DRWG has been working at like a different level. What you're seeing are kind of working their way through like the little niggly things that affect data set interoperability. So, you know, often down at the individual attribute level where, you know, that the standard or whatever is being used has some, you know, options in there where you could do things one way or another. And Peter's saying, well, these things are well known. Well, they are to the sort of the seasoned practitioners in the community, but to somebody new coming in, you know, these may not be obvious and well known. And that's kind of the point of DIWG, working through some of these things that, you know, people are still doing slightly differently that just interfere that little bit and just make interoperability that bit more complicated. So just trying to sort of deal with some of those nitty-gritty little things.
Okay, well, we got 8 minutes for the discussion.
On exactly that point of the little niggly things, you know, when I saw that missing value thing that deprecated, it just reminded me that I think one thing this working group did, maybe with the help of Charlie Zender, was remind us not to use NaN for fill values. And you see those all over the place. And there's a fascinating, if you're interested in that, there's like a fascinating thing that Charlie Zender, he wrote a little essay on why not to use NaN. It's really, it blew my mind.
By the way, there is one recommendation DWG that says don't use NaN.
Yeah, that's where I discovered this. Yeah.
Oh, okay. All right.
Charlie Zender is working on compliance scripts, and the first one he did was NaN. Basically, if it looks through your product, and if there's any NaN, it tells you where it is.
So I'm going to make a little bit more trouble now. These attributes are great. We already use them in our merge file converted for AOS project.
Yeah.
Perfect. The tough question would be for LiDAR, radar, spectrometers, the NetCDF file structure all vary a little bit, or HDF. So would you guys to recommend something and also CF compliant? We're already making troubles, like we use multiple feature types. However, for radar, it's going to be really interesting. So it'd be great between you guys and Rama, my mentor, to work out something. That'd be great. So we can just follow. And right now, I think every science team have their good reasons what to do, what not to do. But it'd be great to enhance the interoperability if we have some guidelines or and some reason behind it. Thank you.
Well, for radar, I mean, DIWG was not previously involved in sort of describing data modeling and encoding of various data. That's not what been the role of DIWG. But I will say for CF and radars, there is, I think, called CF radial, something like that. I'm recalling. I was part of an effort. So there is an extension to CF conventions for radar data.
All right, so we're running a little short on time. I wasn't sure if we get time for this, but did want to just introduce this topic of kind of living documents, you know, how we deal with these. So don't run away, Alexander. This is you. So, I mean, this really came with sort of, you know, starting with DPDG. So
Yeah.
if you'd like to sort of introduce, then if people want to stay for 5 more minutes, we can maybe talk a little bit about this.
Well, I can try to get through this quickly. The DPDG, which Rama described, basically there's a version 2, it's under review now. And once that is released, then the editing team is going to be disbanded. And so what comes after that? We expect that there will need to be further updates. And so there's a new ESDS working group called the Resource Center for Data Producers Working Group. And one of our tasks is to develop a long-term plan for the DPDG. Next slide, please, which is my final slide. What is a living document? A living document can be like continuous revisions, like you revise it every day, but we're talking more continual, like once or twice a year. Who should be responsible for this living document? What triggers the governance of the living document, and what would trigger a minor release, what would trigger a major release, and what I don't have here is how we would collect comments. And so we are the Resource Center for Data Producers Working Group, RCDP, yes, and we are discussing this. We're thinking of putting, right now the document is in DPDG is in MS Word. We're thinking of putting it something more Git friendly, such as Markdown, ASCII doc, LaTeX, and or HTML, and put it in GitHub so the whole world can see it. We're still working out the rules. If anybody has an idea of how a document should be, a living document should be worked in the long term, please send me an email, or Rama or Alexander. I'll make sure it gets to the right place. Should we be putting documents in GitHub?
Everybody else does.
Okay. The ESCO does not do that, and we would like to start doing that.
All right, thank you, Peter. So, you know, the topic arose, particularly in this context, in the case of DPDG, but obviously all of our, well, you know, documentation all over the place, but, you know, particularly in our sort of standards and best practices, we're concerned about this. You know, what happens is once, you know, the team develops the specification, hands it over to ESCO, it gets published, you know, the team disbands, moves on to the next project, and the documents sort of get stale over time. So, you know, DPDG is one specific case, but this also has applicability elsewhere. I did also invite John Casterer here. Just wanted him to say a little bit about Earth Data Forum for those who are not aware of it. So no, just a...
Sure, not exactly relevant to the standards here, but it really is something we're making sure we're plugging. It's a forum.earthdata.nasa.gov, and the intention of that is to be a public facing page for kind of in the whole spirit of open science to have any kind of questions go out there. It's very tag based, so we have a lot of different groups in there. It originated with the DACs, and then most of the DACs are on board, but we've brought in GCMD, CSDA has come on board, different orgs, because the tags make it very easy to filter down through there. So very conversation based. So again, it falls within that whole open science thing. The whole purpose is to make things transparent, build a whole knowledge base up so you can easily search it and find answers within there. So just putting a plug out for it.
All right, so I think we're about it. Oh, yeah, we're at our time, aren't we? Okay, so we have 1 minute. So we squeezed a lot in there. I apologize. Sort of the easy folks, you know, will say, "Are we, you know, NASA? You try and fit too much into your meetings, and it's all sort of keep going. That's just how we do it." But I think these are all things we want everybody to be aware of. I think, you know, understanding the standard process. Do look at you know, standards on Earth data. I say there are things there. So combination of you know, data formats, specifications for protocols, best practices, We're trying to work to have common definitions of a whole bunch of things. That's all going through and being published on Earth Data. If you, anybody like to participate, get involved, ESCO staff, ESCO-staff at list.nasa.gov is a good place to get hold of us. We are definitely interested in talking a little bit more, and I'm not sure what our forum is going to be about this concept of living documents, both in the context of DPDG, but also in the sort of wider context. That may be something that may be best done. Well, maybe it's ESIP is a good forum for that type of thing. So, this is not something which is unique to NASA.
Steve, I have a comment that in the Google Doc notes, a lot of people filled out attendance and check-in, and then somebody came in and blew most of them away. So if you can double check that, re-add your name if necessary. And also, I'll check this Google Doc, and if there's any questions that I can answer, I will try to answer them in Google Doc.
Also, we've had a couple people in the meeting chat ask if the presenters will be answering questions in the notes from the meeting. So please check there and answer and discuss with people. Thanks.
All right. Thanks, everybody. Thanks for coming along this morning.